Okay, this is an example of one of the integration techniques, and in this case, integration by parts. So what we have is sorry about that, just the microphone. So we have the integral of e to the negative 3x sine 5x dx. Now, just like you do with integrals that involve powers of x and e to the some power, you want to let u be the part that doesn't have the e in it, because e is easy to integrate. So I'm going to let u be sine 5x. So be careful here, because we're going to be doing some derivatives and doing some integrals, so you got to be extremely careful about what you're doing here. So u is sine 5x. So for me, du is going to be 5 cosine of 5x using the chain rule. So always when you're doing integration by parts, you assign something to u and you also assign something to dv. And in this case, dv for me is going to be e to the negative 3x. So v, if I integrate e to the negative 3x, so if I integrate e to the negative 3x, I need a negative 1/3 in there, so that when I take its derivative, I just get e to the negative 3x. So the integral of dv, which would be giving me v, is negative 1/3 e to the negative 3x. All right, so I'm going to try to be as nice and neat about this as I can. It's going to get a little ugly here, so bear with me. So I have the integral of e to the negative 3x sine 5x, by definition of integration by parts, is u times v. So for me, that's going to be sine 5x. Multiply that by negative 1/3 e to the negative 3x. So it's going to be uv minus the integral of v, which I found to be negative 1/3 e to the negative 3x, and then du, which was 5 cosine 5x, all that dx. All right, so I forgot my dx over here. Sorry about that. So 5 cosine 5x dx. All right, now, the reason why I write it like this is because I want to make sure you see that you do have an equal sign here. You are finding out the value of this entire integral right here. And so I'm going to need the fact that I basically have two sides to an algebraic equation here that I'm solving. And so I'm going to have to do some rearranging eventually. All right, let's clean this up just a little bit, try to make it look as nice as possible here. So keep in mind, I do have a left-hand side. I'm not going to write it because I need the room, but when I go back to the end, I will write this left-hand side here. So I'm going to move over just a little bit and put my equal sign. So it's going to be equal to. So this is going to be negative 1/3. I'm just going to write stuff in a little different order so I can put my constants first. E to the negative 3x times the sine of 5x. And then over here with my integral, I have this negative 1/3 and this 5 that I can combine in negative 5/3. And then I have this negative out here. So when I combine all that, I get a positive, and then I have a 5/3 sitting out here. So I have 5/3 times the integral of e to the negative 3x cosine 5x. Now, there's different things that you can do. That's just one thing that I'm doing. I try to pull the constants out and deal with them when I have to. I'm just trying to ignore them for now. All right. So when I get there, I'm still, again, trying to find out what the integral of e to the negative 3x sine 5x is. So I still have basically the same problem that I had just a minute ago, in that I still have something that, looking at it, e to the negative 3x cosine 5x, really don't have any way that I can integrate that. So for a minute here, I'm just going to work on this integral down here. I'm going to do it in a different color. I'm going to work on the integral of e to the negative 3x cosine 5x, and then I'll come back up and I'll substitute it back into my problem. And I keep forgetting to write my dx's, and I shouldn't. I should be better than that. So I write my dx out there. Alright, so just like I did a minute ago, I'm going to have to do my integration by parts again, because that basically fits another form that you have for integration by parts. So I'm going to let the u be cosine 5x, and we'll see in just a second how this is going to help me. And so du is going to be a negative 5 sine of 5x. Derivative of cosine 5x is negative sine 5x, and I got the 5 in there. So that becomes negative 5 sine 5x. And for me, dv is going to be e to the negative 3x. Don't forget your dx. And dv is e to the negative 3x, so v, just like it was a minute ago, is going to be negative 1/3 e to the negative 3x. Alright, so I have all the pieces that I need to do my integration by parts again. So I have that my integral here, the integral of e to the negative 5x cosine 5x, that integral is uv, so that's going to be negative 1/3 e to the negative 3x cosine 5x, that's u and v multiplied together, minus the integral of v du. So for me, that's going to be negative 1/3 e to the negative 3x, so v du, and what I have for du is negative 5 sine 5x. I'm not going to write the dx because I ran out of room down there. Alright, so this integral here itself is going to be negative 1/3 e to the negative 3x cosine 5x. Now I have a negative and a negative is going to make that a positive, and I still have a negative out there. So it's going to be minus, and then I have a 5/3 again, minus 5/3 times the integral of e to the negative 3x sine 5x. Okay, so this right here, the integral of e to the negative 5x cosine 5x, I found to be this entire expression right here. So I need all of this right here for what I'm fixing to do. Alright, so back up here. Go back up to my problem where I was in black. So where I was in black was right there. So I had a negative 1/3 e to the negative 3x sine 5x plus 5/3 integral of e to the negative 3x cosine 5x. I'm going to pause this for just a second.